This is numbers 20 through 25 on the study guide. On number 20, hopefully you added this figure, which is needed to complete this proof. You're told that P and Q are parallel. So right off the bat, we're given that P is parallel to Q. So then you look and you see that they're indicating that you're supposed to do the linear pair theorem, which means we're looking for a linear pair. If you see up here, we got a linear pair here at 2 and 3. So what does that mean? Well, what we're looking for is that the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Because linear pair theorem says if you have a pair of linear angles, then their measure adds up to be 180 degrees, or they're supplementary. And so we know that these two add up to be 180 degrees according to the linear pair theorem. Well, you are also told here that angle 1 is congruent to angle 2. Why? Well, we already knew that P and Q were parallel. If P is parallel to line Q, then that means we have some angle relationships that are also congruent, such as this set of corresponding angles, angle 1 and angle 2. So that is the corresponding angles postulate, which says if you have two parallel lines cut by a transversal, then the corresponding angles are congruent. So then we have to think, okay, well, what does that help us out with? Well, we know here if the angles are congruent, then their measures are also going to equal each other. So the measure of angle 1 is going to equal the measure of angle 2. And that is the definition of congruent angles, because what does it mean for them to be congruent? It means the measures are equal. And when you answer that question, what does it mean? It means that you're actually using a definition of some sort. And what do we define? What it meant for them to be congruent. And finally, if you look at this step here, step 2, and this, what do they have in common? See, this was a dead end before, and this is a dead end here. And remember, I said you always want to take your dead ends and start to compare them, and I see that they both have a measure of angle 2. So I'm going to replace this measure of angle 2 with angle 1, because they are the same according to this statement. So instead of writing measure of angle 2, I'm going to say measure of angle 1 plus the measure of angle 3 equals 180 degrees. Now, that's exactly what I was supposed to prove. The only thing I have to do is now justify my answer. What did I do? I substituted that measure of angle 1 in for measure of angle 2. So that is the substitution property of equality. On number 21 through 24, we're supposed to tell whether or not lines M and N are parallel if we are given the following information here. And if they are, we're supposed to state the reason. Well, look at this one here. We've got angle 7 and angle 3 are congruent. We're told that. We're given that. If we're given that the angles are congruent, and notice that these are on opposite sides of the transversal, on alternate sides, and these are inside the parallel lines. These are alternate interior angles. So my alternate interior angles are congruent. And we have this theorem that says the converse of alternate interior angles theorem, which says that if you have two alternate interior angles that are congruent, then the lines must be parallel. So it's the converse that allows us to say the lines are parallel. So the answer is yes, and according to this particular theorem. Number 22 has a little bit more work involved, because if you'll notice, they didn't actually give us measures. But what we want to do is we want to take this x equals 8 and plug it in for both. So if we have the measure of angle 3 here equals 15 times the 8 plus 22, let's go ahead and figure out what that is. 15 times 8 plus 22 is 142 degrees. Then let's do it again for measure of angle 1. Measure of angle 1 is equal to 19 times, we're going to replace x with 8, and then we have minus 10. So 19 times 8 minus 10. And that gives me 142 degrees. These angles are congruent. Let's look at what they are. Angle 1 and angle 3 are corresponding angles. Give me a second.
English Honor Society and Art Honor Society. Thank you.
Angle 1 and angle 3 are congruent angles. They are corresponding angles. So, since angle 3 is congruent to angle 1, I can say, yes, these lines must be parallel. Why? Well, we're allowed to say it by the converse of corresponding angles postulate, which says, if the corresponding angles are congruent, then the lines are parallel. Number 23. 7 is congruent to 6. 7 and 6 are what we call seam-side interior angles. Now, seam-side interior angles are supposed to be supplementary if they are going to make parallel lines. So no, this does not allow us to say the lines are parallel. Now, if you look at measure of angle 2 and measure of angle 3, again, we're given a certain value for x, so what we want to do is plug it into both. So measure of angle 2 is equal to 5 times, we're replacing x with 14 plus 3. So 5 times 14 plus 3 gives me 73 degrees. And then we do it again for measure of angle 3, where we have 8 times this x here of 14, and then we're going to subtract 5, so 8 times 14 minus 5, and that gives me that this is a measure of 107 degrees. Now let's look at what the angle relationship is. Angle 2 and angle 3 are same-side interior angles. And so since they're same-side interior angles, that must mean that they're supplementary, which means these two should add up. So 73 plus 107 should equal 180, which they do. So we are allowed to say, yes, these lines are parallel. Why? Because of the converse of the same-side interior angles theorem. Finally, on number 25, with number 25, you'll notice here that we're told that we have vertical and horizontal bars that are parallel, and so now we're supposed to solve for x and y. Well, if you look here, we have angle relationships that are alternate interior angles, so between these two parallel lines, so that means that they're going to be equal to each other. So this 3x plus 2y is going to equal 36 here. And then we look at these angle relationships. This one and this one are corresponding, which means they're also going to be congruent, so we can set those measures equal to each other. So we have 12x plus 2y equals 126, and this is going to form a system of equations. Now what I want to do is I'm going to go ahead and multiply this top one by negative 1. That gives me negative 3x minus 2y equals negative 36 when I distribute the negative 1 to everything. And then I'm going to add straight down. This is going to give me 9x. That will cancel, equals, and then you're going to do 126 minus 36. And when you do that, you're going to get 90. Divide both sides by 9, and x is 10. Now that you know that x equals 10, you're going to plug it back into one of these two. I'm going to go for this one right here. The 3x plus 2y equals 36. Since x is 10, it's 3 times 10 plus 2y equals 36. That's going to give me 30 plus 2y equals 36. Subtract 30 from both sides, and 2y equals 6. And then divide both sides by 2. Y is going to equal 3.